I won't take too much of your time, Astrid. As you know, we're wrapping up the end of our grant cycle, and we
Yeah.
just had a few quick questions for you on your very important project, exploring macrophage differentiation in the context of xanthogranuloma. And as your
Yeah.
proposal shared, you're aiming to assess whether B-cell receptor encoding DNA sequences and ERK activating mutations are mutually exclusive molecular alterations, and also to explore an IPSIs-based in vitro hemopoiesis model to study macrophage differentiation from monocytes and B cells, respectively. So it sounds
Yeah.
like a very important and groundbreaking project. And the first question I have is a little multi-pronged, but just really briefly in lay terms, if you could explain just the background on why you chose these aims. It sounds like there's a few histiocytic disorders that might be involved, but mostly xanthogranuloma, and which impact the project will have on the community and research.
So the scientific foundation of this project really comes from some pioneering work performed by my PhD student Paul Kemps, who has been exploring the National Digital Pathology Data Bank. And from this large data set, which is actually updated every year, we noticed that there's quite a number of patients with xanthogranuloma who also have an additional hematological malignancy. So this phenomenon, having secondary hematological malignancies, is very well established for the Erdheim-Chester disease population, also for patients with Langerhans cell histiocytosis, but for the xanthogranuloma patients, no one has ever really showed evidence, except for a few case reports reporting at least that patients can have a chronic lymphocytic leukemia, but this is more like a clinical observation, and people have thus far not really been diving into the molecular aspects of these disorders. So because we found a substantial proportion of patients with lymphoid malignancies, and because we have this very interesting case that we stumbled across during the Nicholas meeting in Athens 2 years ago, this patient who was presenting during the patient-parent session that we have each Saturday morning, this patient has a history of xanthogranuloma as well as a B-cell malignancy. So we received some material, some biopsies from these patients, and in Rotterdam, together with my research partner, Lisanne Noordam, who is a pathologist in training. So she is like I think you call that a resident, someone who is not yet specialized, but in the training process. So she did the molecular investigations, and she found out that the xanthogranulomas are the macrophages in the xanthogranuloma, which was a skin biopsy from the eye, had the same B-cell receptor gene rearrangement as the B-cells from the lymphoma that was diagnosed in a lymph node from the cervical region. So we have a sort of proof of concept, and we have this data set from the pathology data bank, and we have another 3 cases, at least in our institute, xanthogranuloma plus lymphoid malignancy. So we want to extract the cases via the Dutch data bank, plus investigate the cases that are stored in our own pathology archive. And this is really the basis of the application. So it's a clinical observation, which is, it's very unexpected if you think about hematopoiesis being lymphoid differentiation versus myeloid differentiations. Stem cells make at some point in their life, they make a decision to go left or right. But it seems that in the histiocytic disorders, there are cells that have, let's say, B cell features or T cell features that can still, we call transdifferentiation. They can still go to the other side, to the other lineage. And this is a relatively new phenomenon. And I think because we have the biological tools, the molecular tools to investigate this, we can find hopefully solid evidence that this transdifferentiation is really happening in the histiocytosis population, and that could also explain why there's still a residual part of the population in whom we cannot find an oncogenic driver mutation, like we do in LCAs, like the BRAF or the other MAP kinase pathway mutations. So I think it's a different way of the formation of macrophages that have a little bit derailed function. And the question, of course, is what steps in that different transdifferentiation pathway do you need to go from a lymphocyte to macrophage? And because patient material is scarce, we invested in generating this induced pluripotent stem cells from a patient with recurrent xanthogranuloma disease history. That paper is actually now we just resubmitted 2 days ago. So yeah, but that paper does not contain any information about the iPSCs because we are still in the process of working with these cells. So this is really the basis is just clinical observations with an unsuspected finding of in that Greek patient that really formed together, that formed the basis of this application.
I think that's fantastic. And what I love about this also is it's very patient driven, right? You have patients presenting certain ways and taking that information and seeing that as a something to explore further because there's evidence that this is not a single situation, but potentially an inroad into a lot of really important data. So thank you so much for pursuing it. It's very exciting to hear about the project. And how will the $50,000 help? How will the funding help?
So the funding will be mainly used to do the molecular analysis because this is, yeah, it is very expensive type of analysis. What we try to do is to work together with the various diagnostic how do you say, diagnostic groups, either in pathology or hematology. So we try to make some deals, so to say, because the aim, of course, is to generate as much data on the material that we have. So what we proposed is what we can do at least with the amount of money issued by the HA, but we hope to do a little bit more by smart combinations of so when we combine samples, and you can do, it's a process called molecular barcoding. So you can, for each sample, you can use a specific molecular barcode. So you can pull samples and then do one sequence run. And that makes it more cheap per sample to do the actual sequencing. So we have some tricks to do that, but it really depends also on how fast we can get the material and the processing. But we try to sort of keep the cells, keep the samples and the DNA samples until we have like a few, so we can do the combined analysis. So we try to do it as cheap as possible, and so that we can process, yeah, many samples.
Yeah, it sounds like that'll be very helpful and to be able to have the preliminary data and I know potentially can pursue things down the line as well. So this project sounds very important and very impactful. And also just on behalf of those that are impacted by xanthogranuloma, it's exciting to see a project that's investigating that particular histiocytic disorder. So Astrid, you may have already guessed that the real reason why we asked you to meet with us today is because your project has been selected for funding by the Histiocytosis Association.
That's the best Christmas gift I've received in many years. Yeah, that's a very it's nice, like you explained it. The xanthogranuloma patients with xanthogranuloma, they are a little bit an underexplored population in the histiocytosis community. I think it's because a lot of people think that this is a very benign. You get these lumps on your skin and they're not very dangerous. But I think the more we dive into this population, we find these patients with recurrent disease and the molecular spectrum of these patients really intriguing. And I think we should learn more also to decide whether or not these patients should be kept under surveillance because they may be at risk of developing these additional malignancies. And Yeah, so I think it's important to also explore this population, and yeah, I'm really happy that the HA is supporting this. Yeah, it's and also for Lisanne personally, I explained to you, she's a pathologist in training, and she has the ambition to go for an academic position. So this will help her to build her CV, to show that alongside her training to become a pathologist, a general pathologist, actually specialized in hematopathology. But on the side, she's also doing this special molecular training. So that's a special track within her pathology residency. But if she can show that she's also capable of doing academic research, yeah, it will really help her also to establish this position. And we are aiming to keep her in the Erasmus MC because, yeah, she's very intrigued by the histiocytic disorders. So it would be good to have a second pathologist on board who is keen on these, so who has a real interest, but also is very keen on getting a fast and quick diagnosis. Yeah, it's
Very
not only
exciting
good
to
for
hear.
me, but also important for her.
That's so exciting to hear. It's we love driving forward research, and we also are always thinking about the future of research. And so to have someone who's early in their career also as excited about this, that is incredibly meaningful. And Astrid,
Yeah,
we can't thank you enough for your passion for Histio and the unique work that you do. And this is a very exciting project, and we're thrilled to support it and excited to stay in touch with you over the year and hear what you learn. I think it's going to be
yeah,
very groundbreaking. So we really
yeah.
appreciate you.
Yeah. So the, let's say, the foundation of the work is now published, so that's good. And the good news is that the iPSCs have expanded well. So I have two clones to work with, one with the mutation, one not. And they're currently at the Princess Max. There's some RNA sent to the Maxima Center to see whether they have additional mutations, yes or not. So we have already geared up to really have a sort of kickstart the project in January. So yeah, so I'm very pleased with this announcement. Thank you so much for telling it in person, which is even more appreciated.